Okay, this lecture we're going to talk about sampling and specifically designing the sampling plan. Obviously, the importance of sampling is to be able to draw conclusions about the whole population in a cost-effective manner. So statistical generalizations are made about the population based on the data collected from the sample. So some of the basic concepts that we need to consider, and we've touched on these already. First of all, a census really is when you survey the whole of the population. We've discussed what we mean by population and sample. Sample is just a selection of some of the elements of the population. It could be consumers, it could be small businesses, depending on the nature of your research problem. And obviously representative sample will be one that reflects the nature of the population. And sampling is really just the verb, how one goes about the process to draw the sample from the population. And there are two broad sampling methods. The one is probability and the one is non-probability. So probability would be where everybody has an equal chance of being selected as part of the sample, and that has got implications for the types of statistical tests that one can do, and the generalizations that one can make about the data, as opposed to a non-probability sampling method. The advantage of a non-probability sampling method is really that it's convenience. It's a lot easier to do it, and by implication it's a lot less expensive to do it as well. So the steps in the sampling process are fairly intuitive. You define the population, identify the sampling frame, your sampling methods. Obviously you need to determine the sample size, and select the sample elements, and then clearly gather the data. So it's fairly intuitive, not necessary to spend much time on it from my part. Once again, you can read it up in the book. It's all very clear there, and also once again, if there are any problems, we will make some sort of arrangement for you to send me questions, and if there are particular aspects that you need more teaching on, and obviously we will try and we will Okay, so let's briefly touch on the sampling methods. Firstly, let's have a look at the non-probability sampling methods. There's obviously convenience sampling, and as I mentioned to you, it's really drawn from a section of the population that's easily accessible or available to the researcher. So typically when we survey students, we would just find the nearest student, go to lectures perhaps, or stop people in the corridors and hopefully get them to fill in a questionnaire. There's judgment sampling, where we try and find students, or not students, but sample or people perhaps that are representative of the population. So if we need a diverse group, say perhaps people from different countries in Southern Africa, perhaps Namibia, Botswana, Zimbabwe and South Africa, then we will make sure that we try and get, say for example, equal representation from each of those countries. Snowball sampling, and this is where you need special populations, and I mentioned I think earlier on about a colleague who was doing research into family businesses, and she used snowball sampling. So every time she spoke to a family business, she'd ask them, please give me the names of other family businesses that I can survey. Then lastly, quota sampling is a combination of convenience and judgment sampling. The researcher uses census data to classify the population according to relevant characteristics such as age, income, sex, or geographical area. So you may want to compare, say for example, males and females in respect of certain aspects, in which case you will get an equal quota, or try and get an equal quota of each of those respective genders. Okay, then looking at the probability methods. First of all, simple random sampling is a sampling process in which units of the population are selected individually by a random process. So that could be, for example, every fifth person in the telephone book. Cluster sampling is where research requires that a sample be drawn from populations for which is difficult or even impossible to compile a sampling frame of the elements. So you get clusters of different sample elements. Stratified sampling is a two-step process. First, a heterogeneous population is grouped into a homogeneous strata that are mutually exclusive, and then a random sample of elements is drawn independently from each different stratum using either random or systematic sampling. So for example, you might want to look at startup businesses as opposed to established businesses, and that's the way that one would go about getting an appropriate sample. Yeah, deciding on sample size is quite a tricky exercise, and there's no one size fits all. So it often depends on the nature of the research and practical considerations. For example, the purpose of the study, the size of the population, time and money and other resources available, the type of report required. So as I said, it's very tricky. I mean, one way of doing it, and it's really just for way of illustrating how tricky it is, if you are surveying perhaps perceptions of households, and you go around and you survey presumably randomly different households, one strategy is you weight the samples according to the number of people in the household. So for example, if there are 5 people in a household, you'll weight that 5, and if there's only 1 person in a household, you'll weight that 1. And the reasoning behind that is really that the person that you're interviewing will be representing a number of other people where the household is 5, it'll be representing 5 people. It's a little bit tricky, but anyway, it just gives you some sense of how complicated this deciding on the sample size. Yeah, in terms of determining the sample size, one way is experience. It's fairly arbitrary, and I think that generally one has to try and justify it in one way or another. You can use statistical methods to try and justify it. There are statistical applications that will assist you, and it really looks at the level of confidence, degree of accuracy. You include the standard deviation perhaps, and one way of doing it is using the kind of Rayosoft calculator, but there are other ways of doing it. The Rayosoft is very popular at Fort Hare, but there are other ways of calculating the sample size. One way is looking at the statistical technique used. So for example, with structural equation modeling, depending on the type of or how many questions you ask, how many items are used, how many constructs are used, those all determine the minimum sample size. So that's also an element that might be considered. And that's the end of chapter 10.